Welcome to this tutorial on microservices on cloud. In this video, we'll explore the fundamentals of distributed architecture and understand how microservices are deployed in cloud environments. This architectural approach combines three key elements: a well-designed architecture, cloud infrastructure, and distributed systems working together. Microservices represent an architectural style that structures applications as a collection of small, independent services that communicate over well-defined APIs. Each microservice focuses on a single business function, making it easier to develop and maintain. These services are independently deployable, meaning you can update one service without affecting others. They are also loosely coupled, which means changes in one service have minimal impact on other services in the system. Let's compare the traditional monolithic architecture with microservices. In a monolithic architecture, all components are tightly integrated into one single codebase. Everything runs as a single unit, which can become difficult to scale and maintain as the application grows. In contrast, microservices architecture consists of multiple independent services working together. Each service can be developed, deployed, and scaled independently, providing much greater flexibility and resilience. Microservices offer several significant advantages. First is scalability. You can scale individual services independently based on demand, rather than scaling the entire application. Second is flexibility. Different services can use different technologies and programming languages best suited for their specific tasks. Third is faster deployment. Since services are independent, you can deploy them without affecting the entire system. Finally, there's fault isolation. If one service fails, it doesn't necessarily crash your entire application, making the system more resilient. A microservices architecture consists of several core components. The API gateway acts as a single entry point, routing client requests to the appropriate services. Service discovery automatically detects and tracks the locations of all services in the system. Each service typically has its own database, following the database per service pattern to maintain independence. Message queues enable asynchronous communication between services. Authentication provides centralized identity and access management across all services. Finally, monitoring tracks the health and performance metrics of all services to ensure system reliability. Major cloud providers offer comprehensive services for deploying microservices. Amazon Web Services provides ECS for container management, EKS for Kubernetes, Lambda for serverless functions, API gateway for routing, and RDS for databases. Microsoft Azure offers AKS for Kubernetes, container instances for quick deployments, Azure Functions for serverless computing, and Service Fabric for microservices orchestration. Google Cloud Platform provides GKE for Kubernetes, Cloud Run for containerized applications, App Engine for managed hosting, and Cloud Functions for event-driven services. Kubernetes has become the industry standard for managing microservices in containers. It provides automated deployment, managing the entire container lifecycle and handling rollouts seamlessly. Kubernetes offers self-healing capabilities, automatically restarting failed containers to maintain service availability. It includes auto-scaling features that adjust the number of running instances based on CPU usage, memory consumption, or custom metrics you define. Additionally, Kubernetes provides built-in load balancing to distribute incoming traffic across all healthy instances of your services. Microservices communicate using two main patterns. Synchronous communication involves real-time request-response interactions, commonly implemented using REST APIs or gRPC. When a service makes a request, it waits for a response before proceeding. Asynchronous communication, on the other hand, uses message-based systems where services don't wait for immediate responses. This is implemented using technologies like RabbitMQ, Apache Kafka, or AWS SQS. Asynchronous communication is ideal for tasks that don't require immediate results and helps improve system resilience. There are three main strategies for deploying microservices. Blue-green deployment maintains two identical environments. You deploy the new version to the inactive environment, then instantly switch all traffic to it, ensuring zero downtime. Canary deployment gradually rolls out the new version to a small percentage of users first, allowing you to test in production and mitigate risks before full rollout. Rolling update replaces service instances one by one incrementally, ensuring continuous availability throughout the deployment process. Each strategy has its advantages depending on your specific requirements. While microservices offer many benefits, they also introduce certain challenges. Managing multiple services increases operational complexity compared to a single monolithic application. Monitoring and tracking issues across distributed systems becomes more difficult when problems span multiple services. Maintaining data consistency across separate service databases requires careful design and implementation. Network latency can impact performance since services constantly communicate over the network. Understanding these challenges is crucial for successfully implementing microservices architecture. With proper planning and the right tools, these challenges can be effectively managed.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.